Good morning, one and all present. I am Professor Prashant Mahajan, working as an assistant professor at AISSMS Institute of Information Technology, Pune. So, in the previous lecture, we have seen conductometry, definition of conductometry, and then various terms which are involved in the conductometry. So today we are going to see the conductometric titration. So what is conductometric titration? That means we are going to measure conductance of that titration mixture, and by measuring that conductance we are going to plot a graph. So that is called as conductometric titration. After plotting graph we will get the equivalence point of the titration. So we are going to see basically acid-based titrations. So as we know, there are two types of acid. One is strong acid and second is weak acid. Similarly, there is uh, strong base is there and weak base is there. So there are four types of acid-based titration, like strong acid versus strong base. Then second one is weak acid versus strong base. Third one is weak base with strong acid, and last one is weak acid with weak base. So generally, we are going to take HCl as strong acid and NaOH as strong base. So what happens in that reaction? So we are going to take HCl in the beaker and NaOH in the burette. So we are going to add 1 ml NaOH each time. So as discussed in the last lecture, if the size of that ion is smaller, then the conductivity will be higher. So HCl, it is present in the beaker, so it will dissociate into H plus and Cl minus. So this H plus is small in size, so its mobility is higher, hence its conductivity will be higher. When we are going to add NaOH from the burette, this H plus is going to replace by this Na plus. So that is small, fastly moving H plus, it is replaced by slowly moving Na plus. That's why the conductance of the reaction is going to decrease. That means here is H plus and that H plus is going to replace by Na plus. That's why that conductance is decreases up to the end point. So at the end point, the number of H plus is equal to the number of OH minus. So that is at the end point. After that end point, that conductance is increasing. Why? Because excess of OH minus is added. So OH minus is having higher conductance. So you can see at the start there is a H plus ions which is get replaced by Na plus. So that's why conductance is decreases up to the end point. After that, that conductance is increases because of that excess of NaOH is added. So this is for excess of OH minus. This is for H plus is replaced by Na plus. So this is nothing but the titration of strong acid versus strong base. Now we move to the second titration, that is weak acid versus strong base. So what we are going to do, just we are going to replace this HCl by acetic acid and we are going to see the change. So this is your weak acid, acetic acid, which is present in the beaker, and base is present in the burette. So what we are going to do, we are going to add each time conductance of the solution. So first reading we are going to take at 0 ml of NaOH, means nothing is present in that acetic acid solution. So this is your first reading. So acetic acid is a weak electrolyte, that means it is having lower conductance. When we are going to add this NaOH solution to the acetic acid, this acetic acid is converted to the sodium acetate. That means what? This is weak, this acid is weak acid, that means its conductivity is low. It is going to convert into sodium acetate, which is salt. So this salt is having higher conductivity than this weak acid. That's why that conductance is increases slowly up to the end point. Okay, just a minute. Okay, so you can consider here as there is acetic acid. When we are adding NaOH, this is going to convert into CH3COO minus, sorry, Na plus. At end point, H plus is equal to OH minus, and after end point that conductance increases sharply because excess of NaOH is added. So you can remember it as at end point H plus is equal to OH minus, after end point excess of base is added, and before end point that H plus will react with the OH minus. So this is your second curve of weak acid with strong base. Then we move to the third titration, that is of weak base with strong acid. So in that case, the weak base taken is NH4OH, that is also called as ammonium hydroxide, and strong acid it is HCl. So similar is the case. We are going to take HCl in the beaker and NH4OH in the burette. So as I said, in the first titration, H plus is having higher conductivity than Na plus. Similarly here, H plus is having higher conductivity than NH4 plus. That means this H plus is going to replace by this NH4 plus. That's why that conductivity is decreases slowly up to the end point. So at end point H plus is equal to OH minus, and after end point the conductance will remain same because we are going to add weak electrolyte. So NH4OH is a weak electrolyte or weak base. That's why the conductance is near about constant. So that is your third titration, weak base with strong acid. If you understand first three titration, then you can go for the fourth titration, and you can also plot the fourth titration plot. So you can see weak acid versus weak base. So we are going to consider weak acid as acetic acid and weak base as NH4OH. So during this titration, we are going to take acetic acid in the beaker and NH4OH in the burette. So first reading we are going to take at 0 ml of base added, that is NH4OH added. That means when we take this acetic acid solution in the beaker, directly we are going to dip that conductivity cell in the acetic acid solution, and we are going to note down first reading, that is your 0 ml reading, that is x is equal to 0, and this is your first reading. Then we are going to add 1 ml NH4OH, then 2, 3, 4 like that. So what happens? This acetic acid is a weak electrolyte, that's why its conductance is the lower side. When we are going to add NH4OH, it is going to form salt. That means acetic acid is weaker than the salt form. The salt is ammonium acetate. That's why the conductance is increasing slowly up to the end point. At end point, H plus is equal to OH minus, and after end point, the conductance remains same. Why it is remaining same? Yes, just remember, weak electrolyte has lower conductance and strong electrolyte has higher conductance. So after end point, the conductance remains same because NH4OH added is weak base and it is having low conductivity. That's why the conductance remains constant after the equivalence point. So these are the four titration. You can remember it as like that. You can see. So this is your first HCl versus NaOH. So HCl and NaOH both are strong. That's why that you will get V-shaped curve. Then second, acetic acid versus NaOH. So as we know, acetic acid is a weak electrolyte. So it will start from the uh, lower conductance, and then it will increase because of formation of sodium acetate up to the end point. After that it will goes, or it will increase sharply because of addition of strong electrolyte NaOH, excess of NaOH. Then third one is weak base versus strong acid. So HCl, as we know from the first titration, HCl is having high it is a strong electrolyte, so it is having high conductivity. But when we add NH4OH, that H plus ions is replaced by slow moving NH4 plus. That's why the conductance decreases up to the end point, and then the conductance will remain constant because of addition of excess of NH4OH. And in the last case, both are weak. That's why the conductance is starting from the lower side. That is due to the conductance of acetic acid, which is weak acid or weak electrolyte. And then we are going to add ammonium hydroxide that will form ammonium acetate. So that's why conductance increases slowly up to the end point, and after end point conductance will remain same because of that NH4OH is a weak electrolyte. That's why the conductance will remain same. So that's it from today's lecture. Thank you.